In this video, we want to look at how to solve simultaneous equations, and the method we would use would be the elimination method. So here I have my first question where we want to solve the pair of simultaneous equations. We have 2x take away y is equal to 5, and we have 2x plus 3y is equal to 3. So the first thing we'll do is label our equations. So this first one, I'll call that equation 1, and the second one, I'll call that equation 2. Now, if we look at equation 1, what we have is 2x, which means 2 multiplied by x. We have negative y. Now we understand that there's a 1 from the y, so this is negative 1y. So that's negative 1 multiplied by y is equal to 5. Then for equation 2, we have 2x, which means 2 multiplied by x, plus 3y, which means 3 multiplied by y, which is equal to 3. Now, when we want to solve the pair of simultaneous equations, it means we want to know the value of x and the value of y. Therefore, x and y would be our unknowns. And the value of x in equation 1 would be the same value of x in equation 2. And the value of y in equation 1 would be the same value for y in equation 2. So now the number in front of x is called the coefficient of x, and the number in front of y is called the coefficient of y. Now, the thing about having an equation with two unknowns is that we can't solve it on its own. If we had an equation with just one unknown, we could solve that. So the fact that we have two unknowns, we need a second equation to be able to solve for those two unknowns. If we had three unknowns in an equation, we would need three equations to be able to solve for the three unknowns. So we have two unknowns, therefore we have two equations, so we could solve for the two unknowns. Now, with the elimination method, as the word suggests, eliminate, we want to eliminate either the x or the y by either adding the two equations, that's equation 1 and equation 2, or subtracting the two equations. So now, when we look at 2x and 2x, it's obvious that if we subtract 2 and 2, we will get 0. Now, if you look at this negative 1y and this positive 3y, there's no way we could get 0 by adding negative 1 with positive 3 or subtracting negative 1 with positive 3. Therefore, in this equation, to eliminate one of the unknowns, we'll have to subtract the two equations because 2x take away 2x will give you 0 and eliminate the unknown x. Now, I am going to do other questions with different scenarios, but I'm just going to point this out now. The sign in front of the 2x is positive, and the sign in front of this 2x here is positive. So the signs in front of the two numbers are the same. And anytime the signs in front of the two numbers are the same and the magnitudes are the same, 2 being the magnitude, the sign being positive, when you subtract, you would get 0. If the two signs in front of the numbers were different, you would have to add to get 0. Meaning, if one of them was positive and the other one was negative, addition would give you the 0. If both signs are the same, whether both be positive or both be negative, subtraction will give you 0. So I'm just going to state that I'm going to subtract equation 2 from equation 1. So I'm going to write equation 1, take away equation 2. So I'm going to put those subtraction signs here. So what we'll have is 2x take away 2x, which will be 0. And 0 is nothing, so we don't have to write anything. So this is going to give you 0. Next, what we have here is negative 1y take away positive 3y. So I just pull my calculator up to work out that. So negative 1, of course, on the calculator, you're not going to put the y, so you're just working out negative 1 take away positive 3. So negative 1, see I press this button for the negative, then I press 1. Then we're going to take away the operation, take away. See, different button from this one. Take away. And then positive 3 is the same as 3. So you just press the 3 like that, press equal, and you see that we got negative 4. So therefore, negative 1y take away positive 3y would just be negative 4y. So I'm going to write negative 4y. And then, of course, we have 5 take away 3, which is 2. So now look at what happened here. We went from having equations with two unknowns to an equation with one unknown. Of course, we eliminated the unknown x. So now I have negative 4 multiplied by y is equal to 2. So what I want to do is get this y by itself. So I'll transfer the negative 4 across the equal sign. And now because it's negative 4 multiplied by y, when I transfer it across, the operation will change to division. So I'm going to get y is equal to 2 divided by negative 4. And again, once you are transferring something across and the operation is changing from multiplication to division, the number that you're transferring across will always go underneath. So now 2 divided by negative 4 is negative a half. So y is equal to negative a half. And of course, negative a half would be equal to negative 0.5. So y is equal to negative 0.5. And if you're not sure about how to get that 0.5, just go on the calculator and say 1 divided by 2, because that's what half is, 1 divided by 2, and you get 0.5. Or if you didn't want to break it down, you can go back and put 2 divided by 4, and you see you still get 0.5. And of course, it was 2 divided by negative 4, so the answer would be negative, so negative 0.5. And even if you wasn't sure about the signs, you can put 2 divided by, and put the negative like that, 4. And press equal, and you see you get a negative 0.5. So now that we know what the answer for y is equal to, we can put this answer, substitute this answer into any of the two equations. Because we know here we have negative 1 multiplied by y, and we know y is negative 0.5. Or we can use this here where we have positive 3 multiplied by y, and this is 3 multiplied by negative 0.5. So either one would work. Now the easiest thing to do here is simply use equation 1 where we have negative y. So I'm going to write, we're going to substitute y is equal to negative 0.5 into equation 1. So equation 1 reads 2x take away y is equal to 5. That's equation 1. So that means 2x take away, and y would be this negative 0.5. So I'm going in brackets, negative 0.5, that's the y, and that's equal to 5. So now this means, remember, this negative out here means negative 1. So we have negative 1 multiplied by negative 0.5. So negative by negative is a positive, so you can look at it like that and just get 2x plus 0.5. Or you could say negative 1 by negative 0.5. Again, two negatives are positive and 1 by 0.5 is just 0.5. So either way, you're going to get 2x plus 0.5 is equal to 5. So here we want to get x by itself. So the first thing we'll do is transfer this positive 0.5 across the equal sign. So I just duplicated the line to do that. See, both of them is the same thing. So the first thing I'll do is transfer the positive 0.5 across the equal sign, and when that happens, this positive sign in front of the 0.5 will change to the opposite, which will be negative. So what we're going to have is negative 0.5. And now I'm going to take that negative 0.5 and put it behind the 5 like this. And now what we have is 5 take away 0.5. Okay, of course I could bring the 2x up like this right here. So we have 2x is equal to 5 take away 0.5. Of course, 5 take away 0.5 is 4.5. So we have 2x is equal to 4.5. So again, we have 2 multiplied by x, and we need to get the x by itself. So we have to transfer the 2 across the equal sign, so the operation will change from multiplication to division. So it will go under the 4.5. So what we're going to have here is x is equal to 4.5 divided by 2. So I'm going to go on the calculator and say 4.5 divided by 2 and get 2.25. So we're going to have x is equal to 2.25. And there we have it. We have our answers. X is 2.25 and y is negative 0.5. So we can simply write, answer x is equal to 2.25 and y is equal to negative 0.5. Now in this question, we had the coefficient of x being the same for both equations. Therefore, we were able to eliminate the x. Now let's look at another situation where we had the coefficients of y being the same, and we'll be able to eliminate the y. So here I have my second question. Of course, we are solving the pair of simultaneous equations. we have 9x take away 2y is equal to 20, and we have 7x take away 2y is equal to 12. Now notice, the coefficient of x for both equations are different, but the coefficients for y are the same. Now notice the signs in front of them are the same, being negative, -2 and -2. And as I said, as long as the signs in front of the numbers are the same, and of course the magnitudes are equal, you will have to subtract to get 0. So again, we're going to label the equations, equation 1 and equation 2. We already identified that we'll be able to eliminate the y's because we see -2 and -2 in front of the y's. And the signs are the same, therefore subtraction would work. So I'm going to say equation 1 take away equation 2. So I'm going to put my subtraction signs here. So what we're going to have is 9x take away 7x, and that will give you 2x. So we're going to have 2x. And then we're going to have the -2y take away -2y. And as I said, once the signs in front of the numbers are the same, subtraction will give you that 0. Of course, the magnitudes need to be same for that to happen. But I'll go on the calculator and show you. So now what I'm going to type on the calculator would be -2 take away -2. So -2 take away -2, press equal, and you see you got 0. Therefore, by subtracting, we're going to eliminate the y. So now this would give you 0. 0 is nothing, so we don't have to write anything. So we just put the equal sign. And now we have 20 take away 12, which will be 8. So we write 8 here. And now again, we went from having 2 unknowns to having 1 unknown. And we can solve this equation with 1 unknown. We have 2 multiplied by x, so we know we want to get x by itself. So we're going to transfer 2 across the equal sign, and the operation changes from multiplication to division. So you're going to have x is equal to 8 divided by 2. And of course, when we transfer 2 across and the operation changes to division, it always goes underneath. So we're going to have x is equal to 8 divided by 2, which will be 4. So now that we know the value of x, we could go and find the value of y. And we can use any of the 2 equations. Because in equation 1, this 9x means 9 multiplied by x. So that will just be 9 multiplied by 4. And in equation 2, 7x means 7 multiplied by x, which is 7 multiplied by 4. So this time, I'll use equation 2. So I'm going to substitute x equal 4 into equation 2. I'll use the word sub for short, sub for substitute. All right, x is equal to 4 into equation 2. So equation 2 reads 7x take away 2y is equal to 12. That's equation 2. And of course, where we have the x, we're replacing that with 4. So we have 7 multiplied by x, and x is 4. Take away 2y is equal to 12. So 7 4s are 28, so we have 28 here. Then write the rest of the question, which is 2y is equal to 12. Okay, so I just duplicated this line to show how I'm going to do the transfer in. So what we want to do is get this y by itself. So the first thing I need to do is transfer this positive 28 across the equal sign. So when this positive 28 goes across the equal sign, the sign in front of it will change from positive because you're not seeing anything here, but positive sign is understood to be here. And that sign will change from positive to negative. So as I take this 28, positive 28, transferring it across the equal sign, the positive is going to change to negative, and I'm going to put it behind the 12 like this. Now notice this negative sign remains in front of the 2 because the sign in front of the number is part of the number. So now we have 12 take away 28. So if you're not sure how to do that, just put it on the calculator. 12 take away 28, and you see you got negative 16. So we're going to have negative 2y is equal to negative 16. And now when we transfer this negative 2 across the equal sign, because remember we want this y by itself, the operation between the negative 2 and the y is multiplication. So you transfer that across, it will change to division. And remember, it's always going underneath. So y is equal to negative 16 divided by negative 2. Now notice the sign didn't change here from negative to positive. It remained the same. What was taking place was multiplication to division. So now what we have here is that we are dividing two negative numbers, so the answer will be positive. And 16 divided by 2 is 8. So we're going to get positive 8. So y is equal to positive 8. So my answer will be x is equal to 4 and y is equal to 8. Now, so far, we looked at eliminating the x, and here we eliminated the y. Now, let's look at a scenario where we have the signs in front of the numbers being different, the magnitudes being the same, but the signs in front of them different, and we'd have to add to eliminate that unknown. So here we have question 3. Of course, we're going to solve the pair of simultaneous equations. The first thing we'll do is label the equations. So equation 1 and equation 2. Now, if we look at the coefficient of x in equation 1 and the coefficient of x in equation 2, they are different. So there's no way we'll be able to get 0 using the x's. But if we look at the y's, we have, well, there's a 1 in front of the y, so that'll make it negative 1y. And here we have positive 1y. So the magnitudes being 1 are the same. So therefore, we would be able to eliminate the y, but the signs in front of the numbers are different. One is negative and one is positive. So as I said, if the signs in front of the numbers are different and the magnitudes are the same, and here the magnitudes are 1 and 1, they are the same, you will have to add to eliminate. So I'm going to write equation 1 plus equation 2. And what I'm going to do here is put some plus signs. So now we have 2x plus 3x, that will give us 5x. So here we're going to get 5x. And watch this now, we have negative 1y plus positive 1y. So if you go on the calculator, what you'll type is negative 1 plus positive 1. Let's see if we get 0. So I'm going to type in negative 1 plus positive 1. So that just be put in 1, right? That's positive 1. Press equal and you see that you got 0. So now 0 is nothing, so we're not going to write anything. So now we just put the equal sign and we'll have 5 plus 10, which is 15. Now it's simple. We have one unknown, so we transfer the 5 across because it's 5 multiplied by x. So when 5 go across, turn to division. So we have x is equal to 15 divided by 5. So x is equal to 3. And now we're going to take that x is equal to 3 and substitute it into either equation 1 or equation 2, any one you want. So this time I'll go with equation 2. So I'm going to substitute x is equal to 3 into equation 2. So equation 2 reads 3x plus y is equal to 10. That's equation 2. And remember, this 3x means 3 multiplied by x. So we're going to have 3 multiplied by x, and x is equal to 3. Then we're going to write the remainder, which is the plus y is equal to 10. And now we have 3 by 3 is 9. Plus y is equal to 10. So now we want this y by itself, so we have transferred this 9 across the equal sign. And we should know by now that this positive 9, when we transfer it across, will turn to negative 9. But the sign in front of it will turn to negative. So the positive y remains on this side. The 10 is here. And we transfer the positive 9 across, and it turns to negative 9. 10 take away 9 would be 1. So there you have it, your answer. X is equal to 3 and y is equal to 1. Now, so far, these 3 questions were nice. You always had a way to either eliminate the x or the y. So what if the magnitude of the numbers in front of the x's are different and the magnitude of the numbers in front of the y's are different? What do we do then? Well, that's why we have question 4 here. Of course, we're solving a pair of simultaneous equations. You know, the first thing we're going to do is label the equations. So we have equation 1 and equation 2. Now let's see. We have 4x and 3x. So the coefficient of x here is 4 and the coefficient of x here is 3. They're different. So there's no way to get 0 if you add 4 and 3 or take away 4 and 3. If you look at the y's, the coefficient of y here is -3, and the other one, the coefficient of y is -2. There's no way to get 0 if you add -3 and -2 or subtract -3 and -2. So what do? Well, I have a simple method for handling that. You're going to take equation 1, and you see this number here, this first number 3 here in equation 2. I'm going to multiply equation 1 by this 3. Then I'm going to take this equation 2 and multiply by this 4 here, which is the number in front of x for equation 1. So this is how it's going to look. I'm going to say equation 1 multiply by 3. Where did I get this 3? The number in front of x for equation 2. So I'm going to multiply 4x by 3 and get 12x. I'm going to multiply this -3y by 3 and get -9y. Then I'm going to multiply this 8 by 3 and get 24. And since this looks different from the other two equations, I'm going to call that equation 3. But essentially, I use equation 1 to form equation 3. Then I'm going to take equation 2 and multiply it by this number here, this 4 here. That's the number in front of x for equation 1. So I'm multiplying by 4. So I'm going to multiply this 3x here by 4 and get 12x. Now notice something. We are 12x and 12x. They are the same, so we could get 0. Now let's continue. We multiply this -2y by 4, and we get -8y equal to, multiply this 10 by 4 and get 40. And of course, this looks different from all the other equations, so we're going to call that equation 4. But essentially, I used equation 2 to form equation 4. So now what do we have here? As I said, we have 12x and 12x. So now we are able to eliminate the x. Both of them is positive 12x, so subtracting will give us 0. So I'm going to say equation 3, take away equation 4. So I'm going to put my subtraction signs here. So now 12x take away 12x is 0. That's nothing, so we don't write anything. And now we have -9y take away -8y. So let's work down the calculator. So you'll put -9 take away -8. So you're going to use this button here for -9, then take away here, different button, take away, and then -8, using back this button here, -8. Press equal, and we get -1. So this -9y take away -8y will give us -1y. So we have -1y is equal to, and now we have 24 take away 40. So you're going to work out 24 take away 40, like that, and we get -16. So we write -16. So now this -1 is being multiplied by the y, so when we transfer it across to get the y by itself, it's going to change from multiplication to division. So we're going to have y is equal to -16 divided by -1. So we are dividing two negative numbers, so we're going to get a positive answer. And of course, 16 divided by 1 is just 16. So we're going to get y is equal to positive 16. So y is equal to positive 16. So now we're going to substitute this y is equal to 16 into any of the 4 equations. So we can use equation 4, 3, 2, or 1. So usually the equation 3 and equation 4 have bigger numbers than equation 1 and equation 2. And you know you don't want to stress out yourself, so just use the equation with the smaller numbers. And that will be either equation 1 or equation 2. So this time I'll use equation 1. So I'm going to substitute y is equal to 16 into equation 1. So equation 1 reads 4x take away 3y is equal to 8. That's equation 1. So this would be 4 multiplied by x take away 3 multiplied by y is equal to 8. So 3 multiplied by y, and y is 16. So we have 4x take away 3 multiplied by y, and y is 16, is equal to 8. So I'll write that 4x, take away, and I'm going to multiply 3 by 16. So 3 by 16 is equal to 48. So here we have 48 is equal to 8. So what we want to do is get this x by itself to solve for x. So the first thing we'll do is transfer this negative 48 across the equal sign, and we'll change to positive 48. So we're going to have 4x is equal to 8, and this goes across and turns positive 48. And 8 plus 48 is 56. So 4x is equal to 56. And now we have to transfer this 4 across, and the 4 is being multiplied by the x. So when we transfer it across, the operation will change to division. So we get 56 divided by 4. And 56 divided by 4 is equal to 14. So x is equal to 14. So my answer would be x is equal to 14 and y is equal to 16. And that will bring us to the end of this video using the elimination method to solve simultaneous equations.